the integral of 1 over a squared plus x squared dx is equal to 1 over a inverse tan x over a plus c derived. It means we need to show that that is equal to this. So we can start by saying the integral of 1 over a squared plus x squared dx. I'm going to divide the denominator by a squared because I want to make this 1. So integral 1 over a squared plus x squared over a squared, which means I'm taking a common factor of a squared out, and if I multiply out the bracket, a squared, we cancel that a squared, and that a squared, we cancel that a squared. I get that back, and therefore I can write, now this is the x. I can then write, this is 1 over a squared. 1 over a squared, I can bring that out. Integral of 1 over a squared will be 1 over that a squared over a squared is 1 plus this is x over a all squared dx. Now I need to do a substitution. I have to say let x over a equal to tan theta. Therefore x equals to a tan theta. I need to differentiate this because I want to make dx. So I can replace dx, so I have to differentiate that. Dx equal to a sec squared theta. If I differentiate tan theta, I get sec squared theta. So that's dx d theta. I need to make dx the subject, so dx equal to a sec squared theta d theta. I multiply both sides by the theta. Now I can carry on here and rewrite this as, so that will be equal to, well, I know what dx is, which is that one, so I'm going to put it there. So integral 1 over a squared, and the dx is a sec squared theta d theta over 1 plus, well, this is a over x squared. A over x squared is tan theta, so that will be tan theta squared, because if I square that, I square the tan theta, and that can be written as, for the a we cancel a here, so you're going to get 1 over a integral sec squared theta. The trig identity, we know that to be the trig identity that we're familiar with is tan squared theta plus 1 is sec squared theta, the trig Pythagorean identity. And so I'm going to have here sec squared theta d theta, and that will cancel each other out. And finally, I can write the integration to then be the integral of 1 over a squared plus x squared dx can now be written as 1 over a integral of sec squared theta. We cancel sec squared theta, so I'm going to get d theta. When integrating, if we have x to the power of n and I want to integrate that, I then do the integral of x to the power of n is always equal to x to the power of n plus 1 over n plus 1 plus c. Now, there is no theta here. The x is theta in this case. There is 1 here, so I can put 1 there. And so if I'm integrating that, it will be 1 over a integral of theta to the power 0 d theta, because that 1 is theta to the power 0. Anything to the power 0 is 1. So I can use this because that will be theta to the power of n. So that's theta to the power of n. N is 0. You can use that to integrate these. So I'll get 1 over a as theta 0 plus 1. That will be theta 0 plus 1 over 0 plus 1 and plus c. Theta 0 plus 1 is theta, so this is going to give me 1 over a theta plus c. But what is theta? Well, I can rearrange this and make theta the subject. To make theta the subject, I can do that here. So theta will be, well, theta will be from there, it will be inverse tan, because if I divide that by tan, I divide that by tan, I get theta on its own, and 1 over tan is tan to the power minus 1 in the indices, and that will be of x over a. So that's what theta is. So I'm going to replace that with theta, which I can then write as equal to that integration now. So let's use it. That integration now equal to 1 over a theta, which is tan to the power minus 1, x over a plus c. So that's the integral of 1 over a squared plus x squared dx. And that will be the final result.